Hello, Jadin. How are you?
Hello, I'm pretty good.
How are you doing?
Pretty well. Just
We begin in a few minutes. You know, I changed the time, so I know some will be a little bit late. So just next 5 minutes we start. Okay. Hello. Can you hear me?
okay, that's fine.
All right. So I think we can begin now. We can start now. Now today will be our last day of class because I figured there's no point keeping you since we have only 1 week left. So I want to give you that time so that you can complete the remaining assignments and then take your final exam. So that means that today will be our last day. After today, all you have to do is to complete the rest of your assignments, complete your projects, and then complete your final exam. The final exam, I will make it available tomorrow night. So you can take it tomorrow night or you can take it any day, but make sure that you take it by 16th, which is a Sunday night, 59 p.m. After that, it will cut off. You will not be able to take it again. Okay. So I want to put it on time so that you have this time. Choose any time that is convenient for you and take it. And the final exam is only one attempt. So be careful. Do your best. I would say. I will make it to be only 10 questions, 1 question from each topic that we covered. So there's no panic. It's just a part of your grade. I think it's 25% of your grade, I think, of your total grade. Now, we're not going to spend so much time today again. I just want to round up. There's no need going to multiple regression. We just talk about simple regression. That should be enough for us. And the last class, I introduced that. I explained the meaning of regression and correlation. I also introduced you to some concepts like correlation coefficient, coefficient of determination, the regression equation, and so on. So today we'll do one example on that, the way you will see it on the question in the final exam and in their last homework. I think it's homework 13, and then we'll be done. Now, I know that I made a promise to you guys. So if your attendance is up to 80%, like we agreed, after this class, I want you to send me an email, choose one assignment that you didn't do well. I can increase the grade by 10%. That is for rewarding you for good attendance. Okay. So if you check your attendance grade, if it's up to 80%, send me an email after this. I need your response tomorrow latest. Okay, because I want to take care of everything now. Okay. Any question before we start?
No questions.
Nope, no question.
Let us begin. Continue from where we stopped last week. We have so we still on the regression and correlation. Like I said, I've already introduced this. So let's do one more example. The kind of question you see on that is right. I think I put the wrong assignment. Okay, right here. It's right here. Correlation and regression analysis. So these are the concepts we covered last week. The dependent variable, the independent variable, the regression equation, and coefficient or determination. The correlation coefficient R. Say R, I mean rho. But to estimate it, we use R, the sample correlation coefficient. For the population correlation coefficient, we use rho. For the sample one, we use R. Then the coefficient of determination, we covered this last week. And then regression equation, which is y equals to beta 0 plus beta 1 x. where beta y is the dependent variable and x is the independent variable. The dependent variable, as you will recall, are the variable that we have no control over, and the independent variables x are the one that we can control. Now, I showed you this equation, but I mentioned that we'll be using Excel so that you don't have to spend so much time doing it in an exam. So now, let's try an example again. This is the kind of question you will see on the final, and you see it in the last homework too. It says here, make it a little bit bigger. Okay. Good. Now it says the table below shows the mileage and prices in thousands of dollars of 8 cars in a car mart. See the mileage X. This is the price Y. So each of these are in thousands. I just remove the 3 zeros to make them the numbers is manageable. You know, for example, this 21.8 means $21,800. 34 here means 34,000. Oh, sorry, this is mileage. 21.8 means 21,800 miles. 34 means 34,000 miles. 41.7 means 41,700 miles. Now, the price of the car, 16 means $16,000. 11.5 means $11,500, and so on and so forth. Now it says, construct a scatter plot to represent this data. Give me 1 minute. Yeah, I've seen it. Construct a scatter plot. Then calculate the correlation coefficient R. Compute the value of R squared. R squared means the coefficient of determination. Find the regression equation. What is the predicted price for a car with a 45,000 miles? So this 45,000 miles can be written as 45, you know. Is there a relationship between mileage and car price? Is there a relationship between mileage and car price? So, to do this, first of all, like I said, I either use the formula, which I listed here, or Excel. The formula takes a longer time. We didn't have the time to do them this semester, but Excel method will be used. It's faster, and as a matter of fact, when you start working in your different offices, you'll be using a software, not hand calculator. So maybe if you find yourself in a remote village in the Caribbean or any remote village where there's no electricity, and then no other source of power, then maybe you can use calculator. So it's an advantage that we are doing it with Excel. That's the point I'm trying to make here, you know. Now, so let us do this. First of all, let's copy this and put them in Excel. Copy it, and then we'll go to Excel. I've already opened the Excel workbook, so I'm gonna paste it there. And paste it right here. Okay. Be sure to make sure that you put I think paste page. Okay, let me just paste it here like that. Get the idea. So this becomes our, if the left side of it is mileage X, okay. So you have mileage X and then price. So I'm going to make this make it all borders. Okay, I can make it bold. Now we are ready to do the. So once you do the Excel, it will give you all the result at once. That's a good thing about it. Let me bring this down a little bit. Okay, stay here. Now, so let's go. First of all, click on the data. Make sure you're seeing this. Okay, good, very good. You click on the data, and then on data analysis. I'll click on data. Okay, right here. Okay, data analysis. And then from there, yeah, it will open a dialog box. From that dialog box, this is dialog box right here. You can now choose regression right here. And then click OK. Now for the y, see input y range, that is for the dependent variable y, which is the price. So to click on it and then start from here and copy all the way to the last number here. Okay, click back here. Then for the input S range, which is the dependent variable, the mileage, click here. And then take it all the way down. Okay. Now, label, because you clicked names, the names are price and mileage, so you got to check on label. And if you want confidence interval, you can check this. I don't really need the confidence interval. I don't think we do. Okay. Now, let's see other things we need. Line of fit plot. Last time I put it, but it didn't plot it. But let's see if it will plot it this time. I need line of fit plot. Now, okay, let's look at the output range. Output range, where we want it output to be. I want it to be under it. Okay. All right. Okay, I think everything is in. Residual, this, that, there. Okay, we're good. Close. So we can see it gave us everything. You can see this scatter plot right here. See, which give us a trend. Mileage, as the mileage increase. Hello, can you all see this? Hello?
Yes.
Yeah. See, as the mileage increase, the price decreases. See, this is the price. See, it keeps going down as the mileage increases. See, so we have our line of ours. So we have answered. Excuse me. Remember the part A, question A says, construct a scatter plot for the data. So we answered the scatter plot question because it gave us the scatter plot right there. Okay. That's the scatter plot right there. Now, let me move it to this side. That should be good enough. Now, next thing we need is the other question they ask. They ask us to calculate the correlation coefficient R. This one will take you like 20 minutes or 30 minutes. I mean, as you didn't make a mistake if you're using the formula method. Now, but it gives us the answer right away. R, the correlation coefficient R. So you know what we're gonna do? Since we want to answer this question, I'm gonna put our answers here. A part, our solution. Okay. Now it gives us the scatter plot. Let me transfer it to this space. So we'll copy the scatter plot, copy it, and paste it. Okay. Paste it here. So you see, you entered it here. So I'm gonna move it down. So according to this scatter plot, we'll look at it. I can even make it bigger. Yeah. So it shows a downward trend. The scatter plots indicates a negative linear relationship between mileage and price, which means that as the price increase, sorry, as the mileage increases, the price of the car decreases. So now you know this is not always the case. Sometimes there might be that it might be that the mileage increases, car price increases. For example, what do you call it? Antique cars, you know, old cars that are driven in the 1920s. Some people go and get the car and then refurbish them. You know, they're very rare. Then that case they could cost more the older they are. But generally for cars, as the mileage increases, car price decrease. So this is answer to part A. Part B says calculate the correlation coefficient R. So as part B, which is solution R equals, now from our Excel output, you can see the R right here. Let me make this. Okay, good. So you can see the R is 0.75778. 0.75778. That means 0.76. Okay, 0.76. 0.76 is 0.76. Now, it didn't tell us whether it is negative or positive. Now, but here we can see from here we can see the negative trend. It is trending down. So, so we put negative 0.76 here for R. So that's why scatter plot is very important if you're using Excel, so you can see the trend. If it's trending up, it will be positive. The strength of the relationship is strong because as it gets further away from the zero, whether it's going to the left side or right side, that means it indicates a strong positive relationship. You know, so the value R equals 0.76 indicates, or negative 0.76 indicates a strong negative linear relationship. Okay, between car price and mileage and car price. See, so supporting what we have in the scatter plot. Any question on this? Any question?
No.
Now, part C says calculate the value of R squared. That means the coefficient of determination that explain your results. So R squared solution R squared equals, let me see what we have from our Excel output for R squared. R squared, see right here, R squared, make it a little bit bigger. I see R squared equals 0.57423. So which means 0.57, 0.57, okay? 0.57, 0.57, or I can call it 57%. So this means that the R square of 57%, the R squared of 0.57 of 57% means that 57% of the decrease in car price is caused by the increase in the mileage. See? So it means that 57% of it. So it's not all everything about product. Like I was explaining, it doesn't mean that the only mileage determine the price, but it's a major part of it. So 57% of the decrease is called by mileage. So the next question they wanted us to answer is here. It says, find the regression equation. Like I explained last week, the regression equation is the solution. Okay. The regression equation is as follows. We have y equals beta 0 plus beta 1 x. Okay. Now, where the y is the dependent variable, and beta 0 is the intercept, and beta 1 is the slope, and x is the independent variable. So to get the regression equation, we find an estimate for beta 0 and beta 1. We can find that in our Excel output in two ways. You can either put it in the graph, in the chart, and you can get it, or you can just get it from here. See where I have the coefficient. Let me so I have the coefficients. See the intercept and the mileage. I see the mileage here. See? So this is a beta 0 right here. This is a beta 1. Now let me write them down so we can I'll use the approximate value. For example, the intercept is 17.1003358. I'm just gonna use 17.1. And for this mileage is negative 0.0902. I'm just gonna use negative 0.09. So that will give us we have what is the paper? Let me write it on paper so we can just put it in 1 minute. So this will do. So we got beta 0 equals 17.1, and beta 1 equals toxic mileage negative 0.09. So I'm gonna put it there and put it in as so we have that beta 0 equals 17.10, and the 1 equals negative 0.09. So plugging this in, our regression equation is y. So I'm going to use these numbers to replace for beta 0. I'm going to put 17.10 minus for beta 1. I'm going to use my negative 0.09 x. So what does this mean? Remember, this is the slope. The one that is attached to the x is the slope. So what does this mean? Now, remember, these are 1,000. These are in thousands. And I'm going to make it here. See, it means that it's a negative slope. That means decline. Okay. So this slope means that the cost of of the price of cars decline over time at the rate of if you remember when we were doing it, we are using it was this I explained that these are in thousands. Okay, so this the value is you're gonna be 0.09 thousand, which means it's gonna be let me show you, tell you what I mean by that. So 0.09 times 1,000 give us 90. I think 90 it should be. Let's look at see if this most could help us here. Okay, I'm gonna open it up and share it. Otherwise, we move the decimal places according to number of zeros we have this most calculator. 0.09 times 1,000. Okay. 0.09 times 1,000, $90. So we have that may I take you back, $90. $90. So it means that the slope of negative 0.09 implies that the price of cars or the value of the cars, okay, decreases over time at the rate of $90 for each 1,000 increase in mileage per 1,000 miles increase in mileage. Yeah. For 1,000 increase, let me say for 1,000 increase in mileage. So it declines. Why do we say decline? Because it is a negative slope. If it is a positive slope, we say increases instead of saying decreases. Okay. Any question on this? Any question?
No, not for me.
All right. So now let's answer the last question. Then we'll be done for the day. He said, oh, actually two of them. He said, what will be the predicted price for a car with 45,000 miles? So you have your equation here already. As excuse me, I'm gonna have it there. As y, this is for part E. It says solution. We have y equals minus 17.1 minus 0.099 x. Now in this case, it say for 5,000 miles. Remember I told you that all these things are in thousands. So for 5,000 will be just 45. Okay. So in this case, x is 45. Here, x is 45. If x is 45, which means 45,000 miles, then plug it in. Y becomes 17.10 minus 0.09 times 45. And that will give us the answer we're looking for. So let me write it down and then we go to decimals and put it in. 17.10 minus 0.09 times 45. Okay. Let's take good here and then figure it out. So we got 17.1 minus 0.09 times 45. That gives us 13.05. Yes, 13.05. Okay. So I'm gonna take you there. 13.05, which if you change it, multiply by 1,000, that means give us the 13,050. So that means that a car with a mileage of 45, or with a that has a 45,000 miles on it, will cost us $13,050 based on the data we are given. Okay. Now the last one, but not the least, is like a test of hypothesis. Okay. Now we have this. It says here, is there a relationship between mileage and car price? I say use alpha 0.05. Okay. So to use alpha 0.05 is that relationship. So to test the hypothesis, you have to test this claim, you have to state the hypothesis first. There are two ways. There's a way you state in linear regression hypothesis. You have two of them, HO and H1. HO is usually beta 0, the population equal to 0. Or just beta, sorry, the beta is equal to 0. Beta 1 equals to 0. Then 1 not equal to 0. Let me see what I can see now equal to 0. Not equal to 0. So when you say that it is equal to 0, it means that that's another way of saying that mileage and price are not linearly related. Not equal to 0 means that mileage and price are linearly related. Now, for alpha equals to, for let us get the critical value and then get the test results. Okay, we have to go to Excel, see what they give us there. Okay, now p-value will give us now I think p-value will be the fastest way to take this test. So this alpha is giving us the alpha they give us is 0.05. Let me say, okay. Alpha. I remember if you're using the p-value method, if you're critical, if you are your p-value is bigger than alpha, you don't reject. So p-value, let us make this decision properly. Decision, okay. Decision. Okay, alpha is this. Let's see what our p-value. P-value is p-value equals that. Okay, let me see decision. Okay. Okay, let me see. That's good. Now, alpha is 0.05. Is the p-value? We have p-value right here. Our p-values for the mileage, see, so it's right here, 0.02939. So we're going to use 0.029. So that's right here, 0.029. 0.029. 0.029. So if the p-value is less than alpha, we reject more hypothesis. if p-value is greater than alpha, you don't. So in this case, we reject because 0.029 is less than 0.05. Reject the null hypothesis, HO, because 0.029 is less than our p-value, I mean our alpha, which is 0.05. So that means we are rejecting this one. So that means that we are accepting this. So that means the conclusion now becomes our conclusion will be that the price and mileage are linearly related. Questions? Any question before we leave? Any question, class? So we're good there. Now, I want to check here. Before we leave, I want to repeat what I said. Tomorrow, I'll put your final exam ready for you in Canvas. It's gonna be, you're gonna take it in Pearson, my lab. So it is only one attempt. So make sure you be sure to study well before you take it. So if it's tomorrow, and then you have from now till the 16th, which is Sunday, to take it. Now, today will be our last class. So that you will have time to finish the rest of your homework, the project, final exam, and homework, and any other assignment that you have left. Then, don't forget to send me the email when if you check your attendance score and it is 80% or more. So let me take your names, and then we will leave. So I got Aaron's here. Okay, Townsend, Ania. I got Nick Taylor, Chambers. Who is Tina's phone? Who is Tina's father? Tina's TI. Who is she or he? Tina's iPhone. Who is they? What's that name? Hello? Tina's iPhone. Who is he or she? Okay, so I have to have 5, 10, 21. All right. I wish you good luck, the exam, and you have a good day.
You too.
Thank you. Have a good one.
You too. Bye-bye.